million cases. 2.6 million deaths. After a year, vaccines are now available.
Here are 4 examples of vaccines.
However, not everyone is ready for vaccines, so we must learn the science behind the vaccines. Once we understand it, there is nothing to be worried about.
The ultimate aim of vaccine is to introduce spike proteins of the COVID-19 virus into our body to train our immune system to fight the virus. Once inside body, these spikes are swallowed by our immune cell. In the process, specialized memory cells retain information about the virus. So next time the person is exposed to the same virus, the immune system is ready to fight it off.
There are actually 4 ways we can introduce these spike proteins into our body. Inactivated vaccines. Some traditional vaccines achieve this by modifying the virus to weaken or disable it, so that when introduced to the body, an immune response can be generated to the antigen without the virus causing disease. When the immune system comes into contact with the weakened virus, its defense, such as antibodies and T cells, attack the virus or infected cells. In the process, the specialized memory cells take note of the specific antigen and prime the immune system to produce cells and antibodies that will quickly target these proteins. So the next time that person is exposed to the same virus, the immune system is ready to fight it off.
Protein-based vaccines. Instead of using the whole virus, another way to trigger immunity involves just using fragments of it, like the spike proteins. These subunit vaccines have the advantage of being relatively easy and cheap to produce and are incapable of causing disease because these fragments are not able to infect whole cells. However, they are less likely to be recognized by immune cells and may attacking infected cells, which means they may trigger a weaker immune response.
Messenger RNA vaccines. Not all vaccines are designed to introduce antigens into the body. Some work by using cells in the patient's body to produce the antigens themselves. In both cases, the goal is to get the short fragment of genetic code taken from the target pentagon. In this case, the SARS-CoV-2 virus that caused COVID-19 into the patient's cells by hijacking the cellular mechanism. This kind of vaccine mimics the way viruses normally reproduce during the natural infection, but rather than creating copies of the virus, the cell only produces large amount of antigens that then usually trigger a strong immune response.
Viral vector vaccines. Viral vector vaccines achieve this by inserting the genetic code for the antigen into a harmless virus, which effectively acts like a delivery system to get the code into the cells without causing disease. Vector-based vaccines can be complex to develop, but they can trigger strong immune response without the need for adjuvants, and in theory, one type of vector can be used to deliver code for a range of different antigens, which can speed up vaccine development. This is the summary of the 4 types of vaccine.
Hello, my friend. Uncle Tang will zoom with Prof Vaccine and talk about the vaccine. Come, we let him in. Hello, Prof Vaccine.
Hi, Uncle Tang. How's life?
Very good. But no good. Hey, I have question to ask you about the vaccine. I heard that the vaccine normally takes more than 10 years to develop. This COVID vaccine only takes 1 year or less. Safe or not?
Indeed, the COVID vaccine development is fast-tracked, but we need to remember that technologies are advancing. Just like we get better and faster mobile phones each year, the development of new technologies, such as mRNA vaccine technology, makes it possible to develop and manufacture vaccine within a shorter time. Most importantly, clinical trials involving few 10,000s of subjects were conducted to test the safety and efficacy of the vaccines. This is also the reason why countries such as the United States, the UK and other developed countries, only authorize and buy vaccines which have been clinically proven. So in short, the vaccines are safe.
Hey, what a long explanation. I only know you said the vaccine are safe. My auntie just forwarded me a message. She said that mRNA is the gene of virus and can change our genes. Maybe auntie watched too much Spider-Man. She really think a bite by a spider can turn someone into superhero.
It is true that mRNA is the genetic material of coronavirus. However, when injected into our body as vaccine, all it does is instructing the body cells to make virus proteins, which will train our immune system for future encounter. During its time in body cells, the mRNA does not get incorporated into our genome, which is made up of DNA. In fact, it is simply not possible to change our genes simply by injecting mRNA or even DNA. Perhaps most importantly, at the end of the process, the mRNA is destructed and is no longer present in our cells.
Oh, just now I saw a post on Facebook. This friend has recovered from COVID-19 and now he feels like he's an Iron Man, very strong, so he does not need to get vaccinated. Hey. This one I can answer without asking you, bro. So my friend, all you need to do is read the news. Don't you know there are many people get infected again after they recovered? Didn't you realize it is easier to get COVID the second time than they winning the lottery? And don't you know the viruses like X-Men, they mutate like the plastic surgery until the immune system cannot recognize. Thanks Prof Vaccines answering my question today. Let's one day hang out. Bye bye.
Bye bye.
Hey, don't skip first. Let's continue to see how we can convince them.
Get vaccinated.
So we can feel the warmth of our family and friends.
So people can go to work and support their family.
So children can go back to school.
So we can embrace and explore the world.
So
our frontliners are no longer overworked and can live their own lives.
Thank you.
Gracias. Arigato gozaimasu. Danyawa. Obrigado. Merci. Shukran. Grazie. Spasiba. Thank you.
谢谢。
Terima kasih.
Protect yourself.
Protect everyone.
Lindungi diri.
Lindungi semua.